Welcome to Tanu Science. In this video, we'll learn the answers from Laws of Motion chapter in the part of short answer questions. First question, define inertia, give its classification. First, we should know the unbalanced force. Let us consider this is object. When there is no force acting on this object, it will be in the rest. If force acting on the object, it may move or may not move. When it is going to move, when the applied force is more than the friction force, F is greater than F, the object going to move. Suppose if the applied force is less than the friction force, object does not move. So when the object going to move, that force is unbalanced force. So unbalanced force only change the position of object. It may be rest or in motion. So without unbalanced force acting on the object position will not be changed. The inherent property of this object is nothing but inertia. So inertia is nothing but object itself will not change its position in the state of rest or in the state of motion without unbalanced force acting on it. Inertia, the inherent property of a body to resist any change in its state of rest or the state of uniform motion unless it is influenced by an external unbalanced force. So without any influence of external unbalanced force, the body doesn't change its state of rest or in the state of motion. This inherent property of a body is known as inertia. First type, inertia of rest. The object itself will not change its position of rest. Inertia of motion, the object itself will not change its motion. Inertia of direction, that is third one, that object itself does not change its direction. That's the inherent property of a body to resist any change in the state of rest or in the state of motion or in the state of direction. So based on these three concepts, we classified into three types. Question number 2. Classify the types of force based on their application. Like parallel force and unlike parallel force, there are two types. Like parallel force is nothing but two or more force acting parallel to each other in the same direction. This is like parallel force. Unlike parallel force, two or more force acting in the different directions or in the opposite direction on the body. That is known as unlike parallel force. Question number 3. If a 5 Newton and 15 Newton forces acting opposite to one another, find the resultant force and the direction of action of the resultant force. Now F1 take as 5 Newton, F2 take as 15 Newton. The resultant force F is equal to F2 minus F1, because here F2 is greater than F1, so that F1 in the negative sign. Now F is equal to F2 value is 15 minus F1 value is 5. So F is equal to 10 Newton. This is the resultant force. This resultant force acting along the direction of greater force. For example, this is a object. This is F1. This is F2. Here F2 is greater than F1. So this resultant force acting along the direction of greater force. So that resultant force acting in the direction of greater force. Question number 4. Differentiate mass and weight. Mass is nothing but the quantity of matter contained in a body. For example, this is a body. The body contains the matter. This matter may be solid or liquid or gas. So the amount of substance in a body is nothing but mass. Weight is nothing but gravitational force which is acting in the downward direction. So mass, this is weight. It has no direction. So it is a scalar quantity. It has only magnitude. For example, 4 kg, 2 kg, like that. Weight has direction and magnitude, which is acting in the downward direction. So it is a vector quantity. So it has magnitude and direction. So it is a vector quantity. Unit of mass. The SI unit of mass is kg or kilogram. Unit of weight in SI is Newton, or simply you can write as N. This mass is always constant, but this weight is varies from place to place depend on the acceleration due to gravity, because W is equal to mg. When the g increases, W also increases. If the action due to gravity decreases, weight also going to be decreases. So this weight changes or varies from place to place based on the acceleration due to gravity. Now we will see how to write in exam. So mass is a quantity of matter contained in the body. It is a gravitational force exerted on the body. SI unit of mass is kilogram. SI unit of weight is Newton, or simply you can write as N. It has no direction, it has only magnitude, so it is a scalar quantity. But it has direction and magnitude, so it is a vector quantity. Mass is always constant, but weight varies from place to place. Question number 5. Define moment of a couple. Let us consider this is a lid of the water bottle. To open or close, we will be using the moment of a couple. That means consists of two forces. One is a forward, another one is a backward force. The distance between the two forces is taken as S. Moment of couple denoted as a M. Moment of couple is defined as the product of any one of the forces and perpendicular distance between the two forces in the line of action S. Unit of force is Newton. Unit of this perpendicular distance is meter. Now we can see the statement. The product of any one of the forces F and the perpendicular distance S between the line of action of two forces. Unit of force is Newton. Unit of distance is meter. Question number 6. State the principle of moments. This force acting on the rigid body. This may be like parallel force or unlike parallel force. That means F1 acting downwards and F2 acting upwards means this is unlike parallel force. So parallel force or unlike parallel force acting on the rigid body which is in equilibrium. The algebraic sum of the moments in the anti-clockwise direction is equal to algebraic sum of the moments in the clockwise direction. So once again, the principle of moment is nothing but when a number of like or parallel unlike force acting on the rigid body which is in equilibrium, then the algebraic sum of the moments in the anti-clockwise direction is equal to algebraic sum of the moments in the clockwise direction. Statement: principle of moments: when a number of like or unlike parallel force act on a rigid body which is in equilibrium, then the algebraic sum of the moments in clockwise direction is equal to algebraic sum of the moments in the anti-clockwise direction. State Newton's second law. Let us consider this object or a body, a force acting on the object. Before force acting on the object, the initial velocity is u. After acting the force, the final velocity is v. Its mass is m, then m. Mu represents initial momentum, mv represents final momentum. So there will be a momentum change. So momentum change after force acting on the object. This force directly proportional to the change in the momentum. that is dp by dt. The dt represents time rate. So force is directly proportional to rate of change in momentum. This change in momentum acting in the direction of force. So if force acting towards right, the change momentum also acting towards right. Now we'll see the statement. The force acting on a body is directly proportional to the rate of change of linear momentum of the body, or you simply can call momentum. The change in momentum takes place in the direction of force. Its formula for Newton's second law, F is equal to ma. Question number 8. Why a spanner with a long handle is preferred to tighten screws in heavy vehicles? Let us consider this is a spanner, this is a screw. The handle of the spanner is long. To produce large moment of force by a small force applied normally at the end of its handle. This is normally force we are applying. Normally means here perpendicular, the distance, and F is perpendicular. We know that M is equal to F into D. M by D is equal to F. If the distance is longer, that means length of the handle is long, the applied force is minimum. This less force produce the good turning effect in the spanner on the screw, so that to produce larger amount of force by a small force applied normally at the end of its handle. Now we'll see the statement. A spanner has a long handle to produce a larger amount of force by a small force applied normally at the end of its handle. So by applying the small force, we are getting the large amount of force. Question number 9. While catching a cricket ball, the fielder lowers his hands backwards. Why? Let us consider he is a cricket player. He is going to catch the ball by pulling his hands in the backward direction. For example, to catch here, he is going to catch here. If the time interval to catch the ball increases, the impact force on him is decreases. We know that force is inversely proportional to the time. When the time increases, the interval of time to catch the ball increases, the effect of force, the impact or impulse is going to be decreases on his hands. A fielder pulls back his hands while catching the ball for a longer interval of time to catch the ball, resulting in a lesser impulse on his hands. So to increase the time interval, the impulse is reduced. Question number 10. How does an astronaut float in a space shuttle? Consider this space station is an astronaut, both of them moving with huge orbital velocity. The acceleration of the space station g is equal to acceleration of the astronauts a. So g is equal to a. Now apparent weight is double R is equal to mg minus a. Now R is equal to mg, is a equal to g. Astronauts acceleration is equal to acceleration of space station. So g minus g, then g minus g 0, 0 into anything 0. So R is equal to 0. They are feeling weightlessness, but the weight is not reduced. They are feeling like weightlessness. Statement. Astronauts are not floating but falling freely around the earth due to their huge orbital velocity. Since space station and astronauts have equal acceleration, so they are under free fall condition. Under free fall condition is nothing but apparent weight is equal to 0. so that both the astronauts and the space station are in the state of weightlessness. Thank you, students.